Renesas Synergy how-to video, creating a Blinky project from scratch using IAR Embedded Workbench for Renesas Synergy. In this video presentation, we will demonstrate how to create a project for the S5D9 Promotion Kit from scratch using the IAR Embedded Workbench for Renesas Synergy, the Synergy Standalone Configurator, and the Renesas Synergy Software Package. And we will show how to add user code for toggling LED 1 on the Promotion Kit. Creating an application is really easy with all the tools the Renesas Synergy platform provides. The Synergy Software Package, or SSP for short, provides you with all the functions needed and makes using them very simple, as all the functionality can be accessed through intuitive API calls. The Integrated Development Environment, IAR Embedded Workbench for Renesas Synergy, together with the SSC, the Synergy Standalone Configurator, allows you to set up new projects and to tailor all aspects of the Synergy Software Package easily. This way you can concentrate on your application and on writing code that provides the high-level functionality you need. All low-level code is already taken care of by the Synergy platform. If you want to follow the different steps of this demonstration, you will need the IAR Embedded Workbench for Renesas Synergy, the SSC, and the SSP to be installed on your Windows workstation. If you didn't do that already, you might want to review the video titled Installing IAR Embedded Workbench for Synergy before continuing. First, start IAR Embedded Workbench for Synergy from the Start menu of your workstation. Close the Information Center. You can reopen it any time again. Writing a new program always requires you to create a project first. For this, go to Renesas Synergy, New Synergy Project. The Save Workspace As dialog will show. We will give the workspace an easy name, for example, My Blinky Workspace. Click on OK, and the window asking for the Synergy settings will come up. In the first line, browse to the location where you installed the Synergy Standalone Configurator. In the second line, you will need to enter the location of the license file for the Synergy Software Package. If you install the SSP into the default location, the file browser will take you straight to the right folder. Select the only license there and click on Open. The details and rights for your license are now listed. Click on OK to close this window. The next dialog asks for the name of our project. Name it My Blinky Project and click on Save. The project creation wizard of the Synergy Standalone Configurator will now start. Under SSP version, select the latest revision. In our case, this is version 1.5.3, but this depends on which version you have installed on your workstation. Under Board, select the S5D9 PK entry, as this is the board we will use for this tutorial. If you want to hear more about the kit, review the video titled Selecting the Right Renesas Synergy Kit for your next design. The device name will be inserted automatically for you, so there is no need to change anything here. Click on Next to proceed. This is the project template selection screen. A project template may include several items. At the very least, it includes the correct board support package for the board and device combination we just selected on the previous screen. Some templates even include a complete example project, like the Blinky templates below. For our tutorial, we will select the BSP entry. This will include the base board support package for the S5 family of Synergy microcontrollers in our project. Clicking on Finish will load the template for our Promotion Kit. This was also the last action required for creating our new project. The project wizard will now close. With that, the configurator will create the necessary files for the project as a last step. Once this post-processing is complete, the Synergy Standalone Configurator will show. The Synergy Configurator will first present you with a summary of your project. There are other tabs like Clocks, where you can change the initial clock configuration of the project, or the Threads tab, which allows you to add and configure different components. For our small tutorial project, there is nothing to change in this perspective. All necessary settings have already been made by the project wizard, so just click on the Generate Project Content button. This will create additional source and configuration files for your project based on the current settings and adds them to your project. Close the configurator and you will return to the IAR Embedded Workbench for Renesas Synergy. Looking at the Workspace window, you can examine which files and directories have been added. There are several additions to the project, but the file we really need is the file called hal_entry.c. This is the one where we will add our small program. Now open the source file by double-clicking on it in the Workspace window. The task our little application needs to perform is to toggle the green LED on the promotion kit labeled LED1 in a 1-second interval. This LED is connected to one of the I/O ports of the S5D9 group microcontroller on the board, and writing a 0 or a 1 into the corresponding port output data bit in the port function select register will turn the LED on or off. And writing this code is really easy, as the APIs and functions of the Synergy Software Package do most of the work for us. The SSP provides us with an instance of the I/O port driver called G_IO port. This instance has an assigned API pointer called P_API, which points to a structure of possible actions. This structure includes a function named pinWrite, which allows us to write a specific level to the I/O pin. The auto-completion function of the IDE is very handy now. It allows you to select the correct members of a structure or array without having to know them by heart, or by having to type them in manually. The function definition showing tells you that the pinWrite function expects 2 parameters, the pin we want to write to, and the level we want to set the pin to. But how do we know which pin LED1 is actually connected to? For this, we simply use one of the HAL functions of the board support package, which provides us with this information. All we need to do is make a call to the function called r_bsp_leds_get, which returns the number of LEDs on the current board and what pins they are connected to. To collect this information, we need to define a structure of the type bsp_leds_t, named, for example, LEDs, which will be initialized by the r_bsp_leds_get function. With that knowledge, we can now complete our pinWrite function call by using the information in the LEDs structure. The pin LED1 is connected to can be accessed through the P_LEDs member array by using the macro bsp_led_led1 as index. Next, we need to provide the level we want to write to the pin. On the S5D9 Promotion Kit, setting a pin connected to an LED to low using the macro IOPort_level_low will turn this LED on. Setting it to high will turn it off. As we want to have a 1-second delay between the LED toggling, we need another call to a BSP API function, this time to r_bsp_software_delay. This function expects 2 parameters to be passed when called. First, the number of units we want to delay, and second, the base dimension of the units. In our case, this would be 1 as the number of units and seconds as base, represented by the macro bsp_delay_units_seconds. As we want to toggle the LED, we need a second call to the pinWrite function and a second delay loop. Copy and paste the 2 lines you just added, and change the level written in the second call from IOPort level low to IOPort_level_high. To toggle the LED indefinitely, just add a while1 loop around the code. And a quick hint, you can download the full project from the website of the Basics of the Renesas Synergy Platform book if you do not want to type the code yourself. Now that the code is finished, the last step is to compile the project. For that, click on the Make button on the main menu bar and the process will start. The project should build with 0 errors and 0 warnings. And this is actually the end of this tutorial. In this video presentation, we showed you how easy it is to actually create code for the Renesas Synergy platform. The next video of this series, called Debugging the Blinky project using IAR Embedded Workbench for Renesas Synergy, will show you the details on how to download and run the project we just created on the Promotion Kit. Thank you for watching, and we suggest that you have a look at the other videos in this series as well.